So now in my last couple of videos we've been focusing on voltage dividers, and this is really the circuit I was kinda leading up to. So at the power supply rails here we have 10 volts. I set that with my bench power supply, and we got 10 volts at this rail too, because I have these jumpers that go across there. So the negative terminal I have plugged into the blue rail, and there's a jumper that brings it to blue rail, and then same with the red rail. The power supply has these alligator clips that come out, so I got other alligator clips that I crimped to jumper cables and have them plugged into the board. One nice thing too about the bench power supply, I have the current limited to probably about 1.5 amps. So if I accidentally short circuit these, only about 1.5 amps will go through them. Not a big deal, unless it goes through something sensitive to current. So in any case, let's get to the circuit. So as I showed before, we have 5 volts at the rails, and you can also have it go across that way if you want to measure it, and there may be some voltage loss, but for the most part it is 10 volts. Now the output of this trimpot I preset to 5 volts. So I've been talking about voltage dividers with a trimpot, or you could use fixed resistors, multiple fixed resistors going from positive to negative. You can tap into a percentage of the power supply voltage. If I set the trimpot about halfway, we get 5 volts. So now let's look at what the problem is. So this is a LED with a 470 ohm resistor. It's pretty hot, this 470 ohm resistor, and for whatever reason, let's just say I want to protect an LED with 220 ohms, but all I have is a 10 volt power supply and I want to get 5 volts out of it, then we could set the trimpot to 5 volts as we just saw. But as we will see here, I'll put the LED here. This is only a 220 ohm resistor, so since we have quite a bit less resistance here, this resistor of a lower value should provide about the same amount of current that we have going through this LED, because it's a lower voltage. But as you can see, the LED is really dim, and so the problem is the trimpot is a 10 kilo ohm trimpot. So from the positive rail there to over there, we have 5,000 ohms of resistance, and so that is actually what is limiting the current. We have a voltage drop where the output of the trimpot is. Right now it's only outputting 2 volts, and that's because the LED is blocking about 1.6. It's holding it up about 1.6, and then the resistor here is help raising it a little bit. So it's pulling the voltage down towards the negative rail is the problem. So we are going to improve this with the transistor wired as an emitter follower, or you may call it a common collector. So first off, there's going to be a base to emitter voltage drop, and so let's see if I can do this one-handed there. So we want to put this up to about 4.7 volts, or 5.7 volts I mean, and it's kind of sliding out of the board, and there we go. So that's good enough, about 5.7, 5.8, as long as we're close, that's what matters. So we're going to take the NPN bipolar junction transistor. This is a 2N2222, and so flat side's facing us. The left pin is the emitter, middle pin is the base, and the right pin is the collector. We're going to turn it this way, so the emitter pin is down lower on the board, the collector is up higher. The middle pin, the base, we're going to put directly to the output of the trimpot. And now we're going to connect the collector, the top pin right now of the 2N2222, directly to the positive rail. With I got a yellow jumper here, so I'll try to keep the warmer colors on the positive side as much as I can. I'm off one row, and I'm not at a good angle to see what I'm doing, so let's tilt it that way a little more. There we go. So finally got her in. She didn't really want to go in, but she's in now. So the base is to the output of the trimpot. The collector is to the positive rail. Now we're going to take a 1 kilo ohm resistor, this is an important part of it, and put it directly to the negative rail and the emitter right there. So what this does, now we should have 5 volts at that point, because we set the trimpot to 5.7 plus a tiny bit more. We're going to lose about 0.7 volts in that range from the base to emitter, and there you can see it is slightly more, just a tad bit more than 5 volts. So those aren't exact numbers, but they're approximation. So this is close enough. Now we are back to our 5 volt goal that we were aiming for as far as the LED is concerned. So the long lead, the anode, I'm going to put where the emitter is and where that resistor goes to the negative rail. And sorry, I'm blocking the light. Now we're going to grab the 220 ohm resistor again to limit the current through the LED based on that 5 volts. And there we go. You can see there pretty good. Make sure we get it to the cathode, the short lead of the LED. There you go. And now you can see it's about as bright as that LED. A little bit has to do with the angle of the LEDs and which one is brighter, because I've abused some of these and they don't get as bright as they used to be. But another thing is, now we have the load. We measured it without the load before. I'm actually going to the emitter of the transistor, the long lead of the LED, and there you can see we have 5 volts. So it's holding that 5 volts really well. And so that's the problem with voltage dividers. They don't provide much current. But there's ways to just take the voltage that they're outputting. We program the voltage with the knob, and this transistor is working as an amplifier, but not as a voltage amplifier. We are losing that voltage drop from base to emitter. But other than that, we're telling it to output this certain voltage that we programmed there, minus 0.7 volts, and so it is providing whatever current it needs to hold that voltage pretty much spot on to 5 volts in this case. So now this was a somewhat hard build to follow compared to what I normally do, so I figured I would get a better angle here. I turned off the power supply so there's no power coming here, but you can see we have the yellow jumper here to the positive rail, right 1 row away from the output of the trimpot. The 2N2222 facing us now, emitter to the left, base to the middle, collector to the right. So we're going to turn it around I should say, and now the collector is to the yellow jumper, the base is to the output of the trimpot, and the emitter is to the right. And you can see how easily this board tries to push out this trimpot. Last video it went flying about 3 inches into the air all of a sudden, just popped out. So it really pushes on those. It's a bit annoying, but it's a good board, so overall not a big deal. Crappy boards would just the metal would just separate and then hardly anything would connect too well. But any case, now we have the 1 kilo ohm resistor. This is what helps hold the voltage at the output, because there's nothing really limiting anything to the collector. The transistor is going to limit the current to what it needs to hold the voltage at the voltage that we set, and so it uses this resistor to do that. And so now that's it for the emitter follower part of it. You can measure the voltage there, which I think I did before I added the LED, but now I'm going to add the LED. So again, the LED only conducts when the anode, the long lead, is more positive than the cathode, the short lead, by about 1.6 volts. And as current rises, it blocks that voltage, and then as current rises, it blocks even more voltage up to about 2.2 volts at 20 milliamps of current. But in any case, we just slide that in there. So the cathode is down one row there, and since we're going to deal with 5 volts, we can use a 220 ohm resistor to connect from the negative rail to the LED, and I'm at an odd angle there, and there we go, it goes to that row. So in any case, that's the build. It's pretty simple and straightforward. You can just, if you have a voltage you really like, and then you can add 0.7 volts to it, or if that 0.7 volts doesn't matter, but whatever your source is, for whatever reason can't provide enough power, you can use, in this case, an NPN transistor to just amplify that current, just like this. Pretty easy. So this is one of my favorite transistor circuits, the emitter follower. So hopefully you enjoyed the video. Thank you for watching. I did more detailed videos on this circuit, and I'll try to link them in the description in the past, but they don't get many views, so I thought I would do an updated video to briefly introduce the circuit and hopefully make it more interesting to investigate further. So thank you for watching, and I will see you in the next one.